Hello everyone, welcome to Friday Happy Math Hour. Um, I'm excited to be here, and they're going to put a link for those of you that need to go to Math 2412. Otherwise, we're going to get started with Exam 1 review and then go from there. So if you have any questions at any moment, please let me know. Just raise your hand or open your mic and let us know. Okay, so for chapter 2, we've been talking about sets, and we learned that a set is a collection of objects, and we can describe a set in 3 different ways. We can describe it as a word description, a roster form, or a set builder notation. So the first example here is in word description. So it just says a set of whole numbers less than 1,000. And then the next example, or the second line here, is an example of a roster form. And so this is listing the actual numbers. So the whole numbers start at 0 and we go all the way to 999. And then the third example is a set builder notation. And so here we indicate that X is an element of the whole numbers and X is less than 1,000. Now in this section, there's a lot of symbols, and the symbols are important, so I wanted to list them here for us in a table. And so this first symbol stands for it's an element of, and an example here is 3 is an element of this set. So in other words, 3 is inside of this set here. The second symbol looks like the first symbol, but it has a line through it. And for that symbol, we have, that means that the set, it is not an element of a set. So if we can see here, we have 7, and then we have the E with the line through it. That means 7 is not in the set 1, 2, 3, 4, 5. The next symbol is the letter N, parentheses A, and that represents the cardinal number, which tells us how many elements are in a set. So for example, if we had A is equal to 2, 4, 5, 6, then the cardinal number of A is asking how many elements are in that set. And so we have 1, 2, 3, 4, so we would say 4. The next symbol is for equivalent sets. And equivalent just means that the sets have the same number of elements. So if we look at the example, we have A is equal to 1, 2, 4, and B is equal to 5, 6, 9. And so here it tells us that A is equivalent to B. That is just telling us that A has 3 elements and B has 3 elements, so they're equivalent. So equivalent means that they have the same number of elements. Then we have a complement, the complement of set A, that's what the symbol means. And basically the complement is everything that's not in that set. So for example, here we have the universal set, which is 1, 2, 4, 5, 6. And if we have A is 1, 2, 4. The complement is going to be everything that is not in A that is still in the universal set. So everything that's not in A is going to be the number 5 and 6. Then we have this symbol, which stands for subset. And so an example here that I can give you is if the first set is 1, 2, subset of the second set, 1, 2, 4, 5. What this means is that everything in the first set, which is 1 and 2, belongs or is part of the second set. So we can see here that 1, 2 is also part of the second set, 1, 2. And so for the second line here, 1, 2 is a subset of 1, 2. So notice that these two sets are the same. It's still going to be a subset because 1 and 2 is still in that second set. Okay. And then we have a proper subset. So 1, to be a proper subset, it first has to be a subset. So in other words, the elements of the first set should be in the second set. So in this example, 1, 2, it belongs to the second set of 1, 2, 4, 5. So it meets the criteria to be a subset. Now what makes it proper is that the two sets are not equal. So there's always going to be an extra element in that second set. Then we have intersection. Is it an upside down U? The intersection is basically what the two sets have in common. So if A is equal to 1, 2, 3 and B is equal to 1, 5, 6, the element that's common to both is going to be the number 1. So we say that's the intersection. Then we have the symbol for union. And the union means that we're using, or we're taking everything in set A and everything in set B. So the union for this would be 1, 2, 3, 5, 6. And then the last one is what we call the empty set. And there's two symbols for that. So it looks like this or like this. And we can say that's the empty set or the null set. And so an example of that is if A is equal to 1, 2, 3 and B is 4, 5, 6. The intersection is what they have in common. And in this case, A has nothing in common with B. So we say that the only thing that is common is that empty set. Okay, so throughout the presentation today, we'll be using several of these symbols that are in chapter 2. Okay, so one of the things that we want to be able to understand is what a Venn diagram is. So a Venn diagram is basically you have a box that represents the universal set, and the circles represent subsets of that universal set. So in this example, we have the set A and the set B. In the example to the right, we have 3 subsets, A, B, and C. Okay, the complement of a set, which we described earlier as everything that does not belong to A, can be represented in a Venn diagram as follows. So here you have your set A. The complement of set A is going to be everything outside of the circle A, which I have shaded in a bluish color around the box. And so that represents your complement. Now the intersection of two sets, you have the set A and the set B. So the intersection is what's common to both. And we can represent that where the two circles overlap, which is highlighted by this shaded blue color. So right in the middle, that's your intersection. So let's look at the intersection a little bit closer. So if you have these 3 sets, A is 1, 4, 5, 7, B is 2, 3, 4, 5, 6, and C is 3, 6, 9. The intersection of AB is what is common to A and what is common to B. Okay, so here is A, 1, 4, 5, 7, and B is 2, 3, 4, 5, 6. So we can see that set A has 4 and 5, and set B also has 4 and 5. So that would be your intersection. In a Venn diagram, it would look something like this, where in the overlapping part of the circles, you would have your 4 and your 5. The second one, if we look at A and we look at C, we can see that there's nothing in common. And so your intersection is the empty set. And if we look at the Venn diagram, there's nothing in the overlapping part of the circles. Now the union of two sets is everything that is in A and everything that is in B. And that can be represented here by the shaded part, which is shading both circles in the Venn diagram. Okay, so let's look at an example. If A is equal to 1, 4, 5, and 7, and B is equal to 2, 3, 4, 5, 6, and C is 3, 6, 9, then we have A union B. And so the union is going to be everything in A, so 1, 4, 5, 7, and everything in B. So we're going to end up with 1, 2, 3, 4, 5, 6, 7. And then for A union C, we would take everything in A, which is 4, 5, 6, 7, or 4, 5, and 7. Everything in C, which is 3, 6, 9. Okay, so let's practice with these Venn diagrams. So here they give us a Venn diagram and we want to identify what these sets are. So A is equal to everything that we see in the circle A, and that's going to be the pound sign, the money sign, and the triangle. Then we look at, let's look at B. What is everything in B? So everything in B is going to be the number 2, 4, 6, and the triangle. Then it's asking for A union B. So that's going to be everything in A and everything in B. So that's going to be the pound sign, the dollar sign, 2, 4, 6, and the triangle. The intersection of A and B is what they have in common. In this case, they only have the triangle in common. Then we have a complement. So a complement is everything that is not in A. So everything not in A would be 2, 4, 6, and 7. And then B complement is everything that's not in B. So that would be the pound, the dollar sign, and the 7. Okay, so that is going from the Venn diagram to writing down the sets. Let's look at another example. So here we want to identify the universal set. So the universal set is everything in the box. And so if we list that, we would get 1, 4, 5, 6, 3, 8, 7, 11, 9, 12, and 2, which I have highlighted in yellow here. So for B, it's asking for A. So set A is going to be 1, 4, 5, 6, 3, and 8. And then letter C wants B. So B is going to be 4, 5, 6, 9, 7, and 11. And then set C will be 6, 9, 8, and 12. So 8, 6, 9, and 12. And then last, or almost last, E is A union B. So everything in A and everything in B. So that's going to be 1, 4, 5, 6, 3, and 8, 7, 11, and 9. And then the intersection of A and B is going to be 4, 5, 6. And if I was to add another one, let's say if I have A intersected with B intersected with C, then that would be equal to whatever all three have in common, which is going to be the number 6. Okay. All right, so let's continue. So here, it's still a continuation of this, but we're doing some that are a little bit different. So A union C is everything in A with everything in C. So that's going to be 1, 3, 4, 5, 6, 8, 12, and 9. Okay, let's go to the next one. B intersected with C is what is common to B and C. That's going to be 6 and 9. And then the last one, or the next one, A union B union C. So that's everything in A, B, and C. So that's going to be 1, 4, 5, 6, 3, 8, 7, 11, 9, and 12. So everything in the circles. And then the last one, letter J, A intersected with B, intersected with C, would be the number 6. Okay. Okay. So now what we want to look at is equality of sets. So for this, there's 2 ways we can work the problem out. One, for some of us that are more visual, then you probably like the first method, and then for others, you might like the second method. Okay, so let's go ahead and continue. So here, what they want to do is they want to see, is this first set always going to be true for this set? Okay, so one way to do that is we can draw a Venn diagram, and we could we can figure out what's on the left side. So first, we're gonna draw a Venn diagram for this right here. So it says A union B. So we do the parentheses, what's inside the parentheses first, A union B. That's gonna be everything in A and B, which I have highlighted in yellow here. So we're looking at everything in both circles. However, the next part is we have to consider that it's asking for the complement. So the complement of the union of AB. And so that's going to be everything outside of those circles. So what we're looking at here is my answer for A union B complement is everything that is going to be in turquoise. So it's everything outside of the circles. So for A union B complement, your answer is everything in the outside of the circles A and B. What we have to do next is we have to show that this right here will also give us this turquoise area, which is outside of A and B. Okay, so that's what we're gonna try to prove next. So first we break it down. We're gonna do A complement. So A complement is everything outside of the circle A, which I have highlighted in pink here. Then let's see what B complement is. B complement is everything outside of the circle B, which I have highlighted in green in my Venn diagram. Well, the intersection of A complement and B complement is going to be what they have in common. If I could pick up my A complement and set it right on top of my B complement, it would look something like this. Okay. And so the only answer, or so the intersection of both of them can be represented here. The only thing they have in common is the outside of the circles, which is a brownish color that I shaded here. So both of these provide us the same area. So the turquoise area and the brown part area are the same. So we can say that A union B complement is equal to A complement intersected with B complement for all sets. Okay, so that's always going to be the case. So we can say that the sets are equal. Okay, so now we're going to work the same problem out, but we're going to do it a second way. So again, this is your first way, which is to basically we just shade the areas. The second way is to use some numbers to make it a little bit easier to keep track of our information. Okay, so what I would do first is still gonna work with this part first. Okay, so I would draw a Venn diagram and I'm gonna label it A and B. And so what I want to do is I just want to label all this regions. Okay, so for example, this part of A, I'm going to label it as 1. The intersection in here, I'm going to label it as 2. And then this other area for B, I'm going to label it 4. And everything outside of the circles, I'm going to label it number 4. Okay. And so then what I want to do is I'm going to get my sets out of this Venn diagram. So my universal set is 1, 2, 3, 4. A is 1 and 2. B is 2 and 3. Okay, so then what we can do next is we're trying to show that this A union B complement is equal to A complement intersected with B complement. So we do the parentheses first. So we're going to do, I'm going to write down what A is, which is 1 and 2. I'm going to write down what B is, which is 2 and 3. Okay. And then on the right side of the equal sign, I'm going to do the same thing. A complement. So we're going to have 1, 2 complement and B complement, 2, 3 complement. So if I work it out, then we have that A union B. Okay, so if we take the union of this and this, that means to put them together. So we end up with 1, 2, and 3. Okay. And then we still have the complement that we're going to take care of here in a second. Now, if we look at 1, 2 complement, that means everything that's not in that set, which is going to be 3 and 4. And then everything that's not in the set 2, 3 is going to be 1 and 4. And so now we'll apply the complement, and then we'll apply the intersection. Okay, so now we are saying the complement of 1, 2, 3. So everything that's not in 1, 2, 3 is going to be 4. And the intersection of 3, 4 and 1, 4 is going to be 4. So if we can see here, 4 is equal to 4. Okay, so what that means is that this set on the left side and this one on the right side is going to be true. So we can say that this will be equal. So you might be wondering, well, we use numbers, right? So is it only true whenever I use 1, 2, 3, 4? It doesn't matter, because you could have said this is 5, 6, 7, and 8. And at the end, you would still end up with the same answer. So in that case, we would have 8 equals 8. So you're going to end up with a statement that is equal. Okay. So this is one way to work it out. It helps you with not having to worry about the shading, because the shading can become an issue when you have more than 2 sets. Okay. So let's try another one. I think I have another one. Before we try another one, there's something that is called the Morgan's Law. And these are just kind of like shortcuts. Whenever you see A union B is complement is equal to A complement intersected with B complement, well, we already proved in these slides that you will get an equality. It's going to be an equal set. So that you don't have to do it all the time, we can use the Morgan's Law. So if you see this, you know it's going to be true, or it's going to give you an equal set. And the same for this one and this one. Okay, so let's do one that's a little bit longer. It has 3 sets. So you have A, B, and C. So we have A union, parentheses B intersected with C is equal to A union B, parentheses intersected with C. Okay. So again, you can do the shading, or you can do the following. So here I'm going to draw a Venn diagram, and I'm going to label, I have 3 circles because I have 3 sets, A, B, and C. I'm going to label each region. So I'm going to have 1, 2, 3, 4, 5, 6, 7, and the outside of the circles is region 8. Then I'm going to take all of these information in the Venn diagram, and I'm going to create sets. So my universal set is everything in the box, so 1 through 8. A is 1, 2, 4, 5. B is 2, 3, 5, 6. And C is 4, 5, 6, 7. Okay. So now I'm going to go ahead and substitute my information. So I have A union, parentheses B intersected with C. And so I'm going to write down my A. A is 1, 2, 4, 5. Union, and then B, I'm going to write 2, 3, 5, 6. And C is 4, 5, 6, 7. And the same for the right side. All I'm doing is rewriting. Instead of A, I'm writing what it actually is, 1, 2, 4, 5. Instead of B, I'm writing 2, 3, 5, 6. And C is 4, 5, 6, 7. And I left all my operations in place. Okay. So now we can work with the parentheses. So first we're going to take care of, let me get my pen. First we're going to take care of this and this. Okay. So if we look at 2, 3, 5, 6 intersected with 4, 5, 6, 7, they want to know what do they have in common. Okay, so here we have 5 and 5, 6 and 6. So that is what we get here. Notice that for 1, 2, 4, 5, I just rewrote it. Okay, and we can finish the left side first and then come to the right side, but it looks like I did the right side first. So here we have 1, 2, 4, 5 union with 2, 3, 5, 6. That means we're going to put all of it together, and that's how we get 1, 2, 4, 5, 3, 6. And then 4, 5, 6, 7, I just rewrote it here. So now we're ready to continue. So now we're looking at, we have 1, 2, 4, 5 union 5, 6. So 1, 2, 4, 5 union 5, 6 means to put it all together. So that is right here. And on this side, we have the intersection. So we have a 6, a 6, a 5, and a 5, a 4, and a 4. So we get 4, 5, 6. So if we compare both of these sets, then we can see that they're not the same. So we say that this is false. It's not going to always be equal. So we say that it's false. Okay. All right. So the next example is an application of sets and how we can use the sets. Okay, so let's go ahead and look at the problem. And here it's telling us that we have a music survey. So in this survey, we need to figure out, they're going to ask us some questions. So we don't see the questions right now, but it says a music teacher has surveyed 495 students. The results of the survey are listed below. We have 320 students like rap music, 395 students like rock music, 295 like heavy metal and music, and 280 students like both rap music and rock music. 190 students like both rap music and heavy metal music, and 245 like both rock and heavy. 160 students like all three. Okay. So the issue here is the questions they're going to ask us might not be so simple to solve with the information given to us in this form. Okay. And so, for example, one question that I could ask would be, how many students like only rap? It would be hard to determine that just by looking at these numbers, because we have rap here, we have rap here, we have rap here, and there's some rap over here, right? So a Venn diagram can help us to really look at what information we have here. So we're going to draw a Venn diagram. To draw your Venn diagram, you need to decide how many circles we're going to need. Okay, so to decide how many circles we're going to need, we're going to have to represent it a circle for each of these. So we have rap, rock, and heavy metal. So we're going to need 3 circles. Okay, well, these are the questions that we're going to answer after we do the Venn diagram. So I draw a circle for rap, I draw a circle for rock, and then I draw a circle for metal. And so when you're doing these, the best thing to do is to start with the intersections. Okay, so we want to fill out these intersections here. And the first intersection that we're going to fill out is the one that is the intersection of all 3. So we look at the information here. They do give us that 160 students like all 3. So we can use that number and place it in the intersection of all 3, because 160 students like all 3. And they tell us that from this sentence. Then we're going to look at the intersection of 2 of these type of music. Okay, so let's look at the first one here. 280 students like both rap music and rock music. So if we focus on the rap and the rock circles, we already have, let me just highlight it here with a different color. The intersection of rap and rock is this entire region here that I'm highlighting in a green color, okay? So that's the intersection, and we know that 280 students like rap and rock. So if we look at this intersection of both circles, I already have 160 students sitting there, right? So what I need to do is take my 280 and subtract the 160, and that's going to give me 120 students that I can place in this region here. Okay, so together, if you add the 120 and the 160, you get 280. So that's your intersection of rap and rock. So let's go to another intersection. So now we're looking at the intersection of rap and heavy metal. So again, if we look at those two circles a little bit more detailed, I'm going to highlight it in green. We're looking at, that's the intersection. And here we already know that we have 160 students that like rap, rock, and metal. So what we can do is we can take the 190 students right here and subtract the 160 that are sitting there already. So that's going to tell me that I need 30 students to be placed in this area. So you have 30 students who like rap and metal, but then you have 160 that like all three. So together, the 160 and the 30 gives you the 190. Okay. So now let's look at this third intersection. So the third intersection is rock and metal. So right here, 245 students. So if I highlight the intersection of these three, then we can see that we still have the 160 sitting here. And so if I take the 245 right here and subtract the 160, then I end up with 85. So 85 would be placed in this region here. So now that we've filled out the intersections, then we need to figure out what are these parts of our sets, what are these numbers, okay? So we want to know what this part of the rap circle is, what part of the rock circle is, and the metal circle. And then eventually we'll figure out what's on the outside. Okay, so to do that, we go back to the information. So if we look at the rap, for example, they tell us that for rap, we have 320 students. So now we're looking at only the rap circle, which I'm highlighting or I'm tracing in green here. And for this rap circle, you already have 120 students sitting there. You have 160 students sitting here, and you have 30 students here. So if you take the 120, the 160, and the 30, and you add those three together, you get 310. But we know there's 320 students. So if we subtract, we end up with 10. And that's the number that would be in this region, right here. Okay. So now let's focus on, let's see, which one is it? Let's focus on the rock. So let me highlight the rock circle. And again, we can see we have 120 students, 160 and 85. So if we add the 120, the 160 and the 185, we end up with 365. But we know that there's 395 students that like it. And so if we subtract, we end up with 30. And that's how we get 30 in this area. And in the same way, we can focus on the metal, heavy metal circle. And again, we already have 85, we have 160, and we have 30. So if we add those three together, then we end up with, 275. But they tell us we have 295 students. So if I subtract, I end up with 20, which is right here. So we have all of our circles filled. So the last thing that you want to do is you want to consider how many students were surveyed. So we have 495 students, and we have all these numbers that we already figured out. So if we add all these numbers that I'm putting a check mark next to, we end up with 455. But we had 495 students, so the difference is going to be 40, and that's going to, but we had 495 students, so the difference is going to be 40, and that's going to be out here. Okay. So now that we have our Venn diagram, now it's easier for us to identify the answers for the questions that they had. Okay, so let me see if I have the questions over here. Yes. Okay, so the first question is, how many students like exactly 2 of the 3 types of music? So they only like 2 of the 3 types of music. So that's going to be your 120 because they like rap and rock, so that's 2. That's going to be your 85 because they like rock and metal. That's going to be your 30 because they like rap and metal. So if you add these 3 numbers, 120 plus 30 plus 85, then we get 235. Okay. Then how many students like only rock music? So only rock music would be the students that are sitting in this area. So my answer would be 30. How many students like only 1 of the 3 types of music? So that's going to be these 10, they only like rap. These 30 only like rock. And these 20 only like heavy metal. So if we add the 10, the 20, and the 30, we end up with 60. Okay. So let me ask you one more question so we can call it letter D. And we can say how many students. So how many students okay, how many students do not like any of the 3? Okay, so what would that answer be? So how many students do not like any of the 3? So if we look at the students that do not like any of the 3, that would be everybody that is not in the circles, right? So in our case, it would be 40. Okay, so 40 students are not gonna like any of those music. Maybe they like R&B. Okay, so give me a second. Let me see if I can give you another example. Let me see if I have my book here. Okay, so in the meantime, if you have any questions, please let us know. Let's see. Okay, so let's see. So some of you will be taking your test this week, and maybe some of you will take it next week, right? So let's see, let me just find an example here. Okay, so here we go. So I'll make one that is, let's see. So I'm gonna share, let's share the whiteboard. Okay, and so whiteboard. Okay, and so I'm gonna kind of just write the information that we need, but this is a survey, and there's 110 freshmen. Okay, so this is students. And the survey is asking the students about their high school background. Okay, so on the subjects that they took. So 25 students took physics. And then we have 45 who took biology. I'm just gonna put bio. And then 48, since it's the most, took the best subject ever, math, right? And then 10 of them took physics and math. So I'm using my mouse to write, so I apologize. I don't have my laptop today. And then we have 8 who took the biology class. So I'm just gonna call it bio. And math. And then we have 6 who took physics and biology. And then 5 took all 3. And then it has some questions that we're going to answer. Okay, I'll tell you the questions in a little bit. So again, we're going to draw a Venn diagram, and you have to decide how many circles you need. So they're talking about 3 different subjects. So I'm going to need a circle for physics. I'm going to need a circle for math. I probably should have drawn bigger. Let me see. And then we're going to need one for biology. Okay. So in order to do this, we want to figure out if there's any information for the intersection of all 3. And they tell us 5 people took all 3. Okay, so 5 is going to go in here. Then we can do the other intersections. So let's look at physics and math. So they tell us 10 people, so I'm going to write 10, took physics and math, but we already have the 5 that are sitting in here, right? So we already have 5 that are sitting in here. So we can subtract these 5, and that's going to give us 5. So that 5 is going to go in this intersection. So I apologize there. Let me try to make my circles bigger. Just so it's a little bit better. And just ignore my writing in there. So we said this was 5. And then we got 5 for this. Okay. So now it's important to label our circles. So that's physics, math, and biology. So now let's look at biology and math. So 8 students took biology and math, but we already have 5 sitting in here. So if we take the difference, 8 minus 5, that gives us 3. So we can write 3 in here. And then we have 6 who took physics and biology. So we can write 3 in here. And then we have 6 who took physics and biology. So again, we already have 5 students sitting in there. So the difference is going to be 1. Okay. So now if we look at just physics, they tell us we have 25. But we already have 5, 5, and 1, so that's 11. So we're going to take the 25 and subtract the 11 students that are already sitting in those intersections, and we end up with 14. Okay. Then for math, or let's do biology, has 45. So let me write it down here, 45. And we're going to subtract 9, right? Because we have the 5, the 3, and the 1. So that's 9. And so for biology, we end up with 36. And then last for math, we have 48. So let's write it here, 48. And for math, we have 5, 5, and 3 students already in there. So we subtract the 13. And we end up with 35. Okay, the last thing you want to check, so this is nothing here. Let me erase this. Okay, the last thing we want to check is if there is anybody that didn't take these subjects. So in order to figure that out, we would have to add everything that is in the circles. So we have to add 14, 5, 35, 1, 5, 3, and 36. And then we're going to take 110 and subtract all of that. Okay, and so let's see, what do we get? Okay, so that's 10, and then 30, that's 40, 50, and then 30 more, 80, and then we have 86, 87, 88, 89, 90, and I forgot what I haven't counted, the 4 and 9. So this should come out to 11. So this answer would be 11. Okay, so now what we can do is we can go ahead and, so this was a 99, right? So we can answer the questions. So what are those questions? Let me ask you. So how many students took biology? Well, let's start with this one. How many did not take any of the 3 subjects? Okay, so how many did not take any of the 3 subjects? So those are going to be the 11 here, did not take any of the 3. How many took physics, biology, or math? Okay, so how many took physics, biology, or math? So the number of students who took physics is going to be, so for physics, it's 25 students that took physics, but neither math nor biology. So we subtract the students that are not in math or biology. So we have the 14, and then we're going to have the 35, and then we're going to have the biology. Okay, so if we add all those, then we get the 35 plus the 14 plus the 36. and then we can do the 3, 5, 5, and 1 so that we don't repeat them. So all of these guys took physics, biology, or math. So basically it's everybody in the circle, which is 99. Okay, so that would be your answer there. And then for the next one, how many students took math only? So that would be 35. Okay. And so that was just some examples of how you can use a Venn diagram to help you answer some of these questions. And so I'm gonna go ahead and pass it over. I'm gonna wish you all success on your exams.
Okay, well, thank you so much, Ms. Chuka, for presenting today. Thank you all for coming and being such a wonderful audience, and we definitely hope to see you again soon. So wonderful audience, and we definitely hope to see you again soon. So join us next week, and if you can't, look at the flyer that I'm sharing with you right now. You'll see that for February 13th, next Friday, we'll be covering for Math 1332, logic statements, truth tables, conditional and biconditional statements, and for Math 2412, exam review number 1. So we hope to see you here again soon and have an amazing, amazing weekend. Enjoy the Super Bowl, guys. Thank you for coming. Bye.